Okay, so today we're going to be classifying rational numbers. So when it means to classify a number, it means to identify where they belong. Like, is a number rational? Is it also an integer or a whole or a natural? So to be able to do this, you got to understand what a rational number is. So a rational number is actually any number that you've seen so far, except pi. So a rational number can be fractions, can be decimals, can be negative numbers, can be whole numbers, can be 1, 2, 3, and so on. So a subcategory of rational numbers is called an integer. An integer can be from negative infinity to positive infinity. The only thing is the numbers can't be fractions or decimals. A whole number is from 0 to positive infinity. So a whole number can't be fractions or decimals and also can't be negative. A natural number is from 1 to positive infinity. So the only difference between whole and natural is natural just can't have 0. So we're going to play a game. And what we're going to do is we're going to make this Venn diagram called club math. And what's going on is we have a list of numbers on the outside. And we got to figure out where they belong. So what they're going to do is they're going to enter the club. So 0.5 gets into the club. It's enjoying the music, but it wants to see the other rooms. So it wants to try to get into the integer room. Well, 0.5 can't get into the integer room because it's a decimal. No decimals or fractions can be in the integer room. So 0.5 has to stay in the rational room. Next, number 1 enters the room. So 1 is in the rational room enjoying its time, but it wants to get further into the club. So then it goes into the integer. The reason why number 1 can go be an integer is because it's not a fraction nor a decimal. So it's enjoying the integer room, but it wants to go see what's the whole room number is like. So we can go into the whole room number because 1 is positive. Well, the whole room number is not as cool as they thought, so they want to go to the natural numbers. And 1 belongs in the natural number because it's greater than 0. So it's 1 and so on. So the next number that comes in is 0. So 0 gets into the rational room, enjoying the time, but it wants to go see where number 1 went. So 1 goes into the integers, and the reason why, 0 goes into the integers, and the reason why 0 can be in the integer is because, again, it's not a fraction nor a decimal. And now it wants to go on to the whole number room, and it's allowed to be in there because it's not negative, but 0 cannot go to the natural room because you have to be 1 or greater to be in the natural room. Okay. Negative 1 goes to the rational room, enjoying its time, but wanted to go to the integer room, where it's allowed. Negative 1's allowed in the integer room because it's not a fraction or a decimal. But negative 1 cannot go into the whole number room because it's negative. So only can be in there. So now 1/2. Let me see if I can change my color. So 1/2 can go be a rational, but it can't go be an integer because it is a fraction. So let's recap. 0.5 is only rational. because it's a decimal. It can be nothing else. 1 is rational. So I'm going to put an R for rational. 1 is also an integer. 1 is also a whole number, and 1 is also natural. Because you see how it went through all 4 of these circles, it means it's all 4 of these things. Okay? So it's a natural, it's a whole, it's an integer, it's rational. A 0 is rational, it's an integer, and it's a whole number, but it's not natural because it's 0. Natural numbers can't be 0. -1 is rational and an integer, but it can't be whole because it's negative. And 1/2 is just rational because it's a fraction. So the key thing I want you to understand is all these numbers are rational. So anytime I ask you to classify a number and I give you it, the first thing you say is rational because it has to be rational. The next part is to figure out where else it belongs. And that's what we're going to do. Well, that's what we're going to do right now. So number 37. 37 is whole, an integer, rational, and it also forgets natural. Because if we went back to our Venn diagram, number 37 would belong in the natural category because it's a positive whole number greater than 0. Okay, -56.12 is just rational because it's a decimal. C is an integer and rational because it doesn't have a fraction or decimal, but it's a negative number, so it can't be a whole or natural. And D, 7/8, is rational because it's a fraction. So we're going to try this on our own. So if you want to pause the video and try it by yourself and then pause it and then unpause it to see the answers. Okay, so -8 is going to be rational. And I'm just going to put R for rational because that's the first thing. It has to be rational first. The -8 can be an integer because it's not a fraction or a decimal. But it cannot be a whole number because it's negative. All right, next one. -102.55. Well, first off, it's rational. But it can't be anything else because of the 0.55. Okay, 3 is rational. It can't be anything else, though, because 9/2 cannot simplify. So that means it's a fraction. So that means it cannot be an integer. So 3 is going to be a rational first. It can be an integer because it does not have a fraction or a decimal. It is a whole number because it's positive. And it's also a natural number because it's greater than 0. Hopefully you did good on those. All right, so we're going to do true or false. So true or false, all integers are rational numbers. Okay, this is a true statement. And I'm going to say this again. All integers are rational. Because if you go back to your Venn diagram, these integers first had to be rational. So it means that all these integer numbers had to first be in the rational room. So it makes them rational. So next one says all integers are whole numbers. This is going to be false. I'm going to say this again. All integers are whole numbers is a false statement because if you're here in the integer room, not all numbers will be a whole number because some integers can be negative, but not all of them. So to make this a correct statement, you can say some integers are whole numbers, just not all of them. Okay, so pause the video again, and I want you to answer the true or false and explain your choice. All right, number 6. Tell whether the statement some rational numbers are integers is true or false. Explain. Some rational numbers are integers. This is a true statement. And I'm going to say because, I'm not going to write it out. It says because some rational numbers will go on to become an integer, but not all. You see how here we had some become integers, but like the 0.5 and the 1/2 did not because they're fractions. So we had some of them. So it's true because of that word some. If it said all, it would be false. Describe a real-world situation that's best described by the set of rational numbers. Rational numbers can be anything. It can be shoe sizes, measuring heights, measuring weight, things like that. So this is going to be your exit ticket for the day, and it's actually going to be your grade, so I won't do in the video today. If you do need help on it, come find us. It's always good to ask questions. And as a reminder, it's always good to practice your math at home. Thank you, guys.